Hey guys, welcome to my channel. I don't know how you got here, but I do hope that you'll stay until the end because in this video, I'm going to be talking about fractions, more specifically how to multiply and divide fractions. So the idea of this video came from a specific scene from one of my favorite films, Only Yesterday, which is a Studio Ghibli film you should definitely watch. Okay, so in the film, the main character, Taiko, is having trouble with fractions. She's having trouble with dividing fractions more specifically. And when she shows her mother her grades, her mother is not quite happy, so she tells her sister to teach her how to do it. The specific equation that's in question is 2/3 divided by 1/4. Okay? So, what happens is the sister explains that in order to get the answer, you have to multiply by the reciprocal, which Taiko doesn't completely understand why that's the case. What she does is she draws an apple and she divides it into 2/3, or she divides it into thirds, sorry. Right? And then she shades in 2/3 of that apple. Okay, let's say that's shaded in. And then she explains that the reason she got the answer that she got, which is going to show up as 1/6, is because she divided those 2/3 into 4, which is this fraction here. So if you get 1/4 of this, right there, that is 1/6 of the whole apple. Okay? So once she shows her sister how she gets the answer, her sister then scolds her and tells her that is actually multiplication, which is correct. That is multiplication. The reason that is multiplication is what you're doing is you're actually taking the 2/3 of the apple and timesing it by 1/4, which is this right here, right? What you want to do in order to divide is actually you take the apple, you still divide it by 2/3, okay? And the 2/3 is right here. Right? But the problem is you're dividing it by 1/4, which means you're taking 1/4 of the apple, so we're going to use a different color here. And I'm going to divide it right here, actually, in this line. Okay, you're also going to divide the apple into 4, okay? And you're going to take 1/4 of that apple. Now the question is, how many times can you divide this 2/3 of the apple by 1/4 of the apple? So that's the mistake that Taiko made. And you can see here that the answer, so you have 1 whole, 1/4, 2/4, and then you have another piece that is not exactly another fourth. So we call this the remainder, of course. But if you express that in a proper equation, what's going to happen is you're going to get the answer 2 and 2/3. It's because you have 1 whole quarter, 2 whole quarters, and then you have this remainder here. So we need to prove that that remainder is 2/3. Okay? You're not going to be able to find that out just by drawing it. One way or another, you have to show your solution, okay? So the way we're going to do that is we're actually going to turn this equation into something that we can, I guess, digest better. And the way we're going to do that is we're going to turn it into a fraction. So 2/3 over 1/4 is the same thing as 2/3 divided by 1/4. So in basic algebra, we have to try to get rid of this 1/4, okay? And the way we're going to get rid of it is we're going to make it equal to 1, because a number over 1 will always be the number on top. Very confusing, right? So let's make it make sense a bit more. The bottom number is the denominator, the top number is the numerator, okay? So a numerator above 1 will always be equal to the numerator by itself. Does that make better sense? I hope so. So how do we make 1/4 equal 1? We times it by its reciprocal. That's right. Whatever we do down here to the denominator, we also have to do to the numerator. So we're also going to times that by 4/1. Okay? So what's going to happen now is this will equal 1. That's right. And the top will equal So when we multiply fractions, we just do it straight ahead, okay? Straight there, straight there. So it's 8 over 3, okay? So 8 over 3 over 1. And as I said earlier, when the denominator is 1, whatever is the numerator, that will be the answer, right? 8 over 3. So that is the answer. So we can still simplify 8 over 3. And we do that by dividing how many times 3 can go into 8, which is 2 times, okay? So it equals 2. So in order to get the remainder here, we're going to have up here 8, 2 times 3, so that's 6, minus 6 over 3. And the final answer is, in unison please, 2 and 2/3, which is right here. That's how we got the answer, okay? Now, this is all the correct answer, but this is the problem, I suppose, with it when you're kind of creative, when you have an imaginative mind. This won't register to you properly. So let's go ahead and get rid of the explanation here. And we're going to go back to our, So we're going to go ahead and go back to our main question, 2/3 divided by 1/4, okay? And the rule is you always multiply by the reciprocal. So that would mean that this will now equal 2/3 times 4 over 1. In terms of percentages, this doesn't make sense, okay? Because now we have to use the idea of the apple. And this is probably where Tycho could not understand it properly. Because what happens is, if we were to use the example that Tycho does, what we have is our first apple, right? Okay, first apple, and we're going to divide that again into 2/3. Okay, and I'm going to use the red again. And we're going to get 2/3 of that apple. Okay, so as you can see in Tycho's original mind, she was actually multiplying, which is 2/3 times 1/4 equals 1 over 6. Okay, and that can be proven once again because when you multiply the top, 2, 3, and 4, 12 equals, when you break it down, 1 over 6. And we also have her very creative way of trying to interpret the equation to the example of the apple. That all shows that it's correct. Now we have 4 over 1, which means we're multiplying this 2/3 by 4. I'm going to draw it in the best way I can, but it's not going to be very perfect. But okay, here we go. So actually, this is what it looks like. Okay, confusing, right? 2/3 times 4 over 1, and we're trying to get back 2 and 2/3. So we have here 2/3, okay? And then I need another color, one moment. 2/3 times 4. So we need another 2/3. Why? Because it's 4. So this is another 2/3. Okay? 2/3, 2/3. Now we need another 2/3, which will be and we need one more set of 2/3. And we're going to make that one pink. Why not? Okay, 2/3 for 1. All right, ready? We're going to count it together. This is the first, second, third, fourth. What happened is, now we have two different representations. What happened now is we have 2 whole apples with the remaining 2/3 apples. So what does that equal? 2 and 2/3. And that's what can make it very confusing if you're kind of imaginative. You want to kind of look at it at its most basic idea, which is this right here. 1 apple, because you're just 2/3, 1/4. That's it. When we end up making it into a reciprocal and then multiplying it, in an algebraic sense, you're getting the same amount, but you're not technically. Because in this equation, you can see 2/3 times 4/1 means you're getting one set of 2/3, two sets of 2/3, three sets of 2/3, and four sets of 2/3. And both answers are the same. However, the way you get to the answer in terms of a creative sense is very different. And that's kind of the difficulty of having a wide imagination. And you know, it's not a bad thing. It just means that you have a different view of things, which you have to kind of adjust in order to get where you need to get. Because as I said, you get the same answer both ways, but visually it's very different. Because in this equation, you get 3 different apples. Of course, the other one is got only 2/3. Whereas in this equation, you only get this one visual apple. In this sense, we just kind of look at it in terms of percentage-wise, okay? So for example, here you kind of get, you still get around 266.6 repeating percent, right? And this one you also get 266.6%, right? But in this image, you only literally get 2/4 and 2/3 of a quarter, whereas in this image you get 2 whole apples and 2/3 of a remaining apple. Confusing? Yes. Is it mathematically correct? Also yes. And you know, I'd like to go further into it on why it works, but we're gonna end that video here because I'm pretty sure it's really hard to follow. It's more of an abstract idea, really. It's a very, very abstract idea of algebra. So we'll just leave it there. So anyway, I hope we can always better ourselves. Take care, everybody, and until next time, bye-bye.